Today we're diving into something that's happening inside your body millions of times a second, every single second. We're talking about the death of a cell.
So what really happens? It's not just one single event. It's more like a fork in the road, a critical choice that leads down two completely different paths.
And here are those two paths. On one side, you've got necrosis. Think of this as a chaotic, messy, cellular crime scene. But on the other side, there's apoptosis, a quiet, orderly, and totally planned event. More like a programmed suicide.
All right, let's start by walking down that messy path. Necrosis. This isn't planned at all. This is what happens when cells die because of some outside force. Think a nasty injury, a poison, or just not getting enough blood. It's pure reactive damage.
The number one thing to get about necrosis is that it's just messy. It's an unplanned collapse. Imagine a building just crumbling to the ground. It throws dust and debris everywhere, right? That's necrosis. And all that debris triggers the body's big red alarm: inflammation.
And get this, necrosis doesn't always look the same. It can be dramatically different depending on where it happens. In the brain, for example, the dead tissue can literally turn into a liquid mess. In something like a tuberculous infection, it gets this weird, soft, white, cheese-like texture. It's kind of grim, but absolutely fascinating.
This quote just nails it, especially for the most common type, which happens in organs like your heart or kidneys. The cells are dead for sure, but their ghostly outlines are still there, like tombstones in a graveyard, marking where a bustling city of cells used to be.
Okay, let's switch gears completely and look at the other path, because this path tells a totally different story. Apoptosis isn't a tragedy. In fact, it's often a heroic and absolutely vital process. This is cell death by design.
So, unlike the total chaos of necrosis, apoptosis is the body's way of, well, tidying up. It's a quiet, internally programmed, self-destruct sequence for cells that are old, damaged, or might become dangerous, like a potential cancer cell.
And this is why it matters so much. Ever wonder why you don't have webbed fingers and toes? Apoptosis. It's what carved them out when you were an embryo. When a cell gets infected by a virus, apoptosis tells it to take one for the team and self-destruct before the virus spreads. Without it, we literally couldn't develop properly or defend ourselves.
And the process itself is just incredibly efficient. First, the cell gets the signal. It's time to go. Then, a demolition crew of special enzymes gets to work, neatly taking the cell apart from the inside. And for the grand finale, the cell breaks itself up into these tidy little packages that are just gobbled up by nearby cells. No mess, no fuss, and absolutely no inflammation.
So if you take one thing away from all this, let it be this. Necrosis is a loud, public disaster that triggers a full-blown inflammatory emergency. Apoptosis, it's a quiet, private departure that leaves the neighborhood totally undisturbed.
Okay, so we've got this clean, orderly process. But let's go back to the messy side for a minute. What happens when necrosis isn't just a few cells here and there, but a huge area of tissue dying? That's when we enter the really dangerous territory of gangrene.
Gangrene is basically necrosis with a terrifying twist: infection. Bacteria get into the dead tissue and they just start feasting on it, breaking it down. This is called putrefaction, and it creates a seriously life-threatening situation. You usually see this in places like fingers or toes when blood flow is poor. The tissue just slowly dies, dries out, and turns black and mummified. And while that sounds terrible, there's often this very clear line between the dead tissue and the living tissue, which actually helps contain the spread.
Wet gangrene, on the other hand, is a whole different beast. This happens in moist tissues, like inside your bowel or lungs. Bacteria go wild in there, causing this rapid, foul-smelling decay. It's way more dangerous because it spreads like wildfire, and there's no clear border, a true medical emergency. And then there's this particularly nasty version called gas gangrene. It's caused by specific bacteria that you might find in soil, and they don't just rot the tissue. They actually release gas bubbles into it. This causes the area to swell up and break down even faster. It is just awful.
Okay, so gangrene is one major consequence of necrosis, but believe it or not, other, stranger things can happen after a cell dies. For instance, sometimes tissues that are supposed to be soft can start to harden up, almost like they're turning to stone. This is called pathologic calcification.
So what is it? Well, it's pretty much what it sounds like. Calcium salts start building up in places they have no business being. And there are two main ways this can happen, which, again, comes down to a local problem versus a body-wide problem.
And this comparison is so key. Dystrophic calcification happens in old, damaged, or dead tissue, even if your blood calcium levels are perfectly normal. It's like rubble hardening at an old construction site. Metastatic calcification, though, happens when you have way too much calcium in your blood and it starts depositing everywhere, even in perfectly healthy tissues.
So when you really zoom out, you see this incredible tension inside our bodies. It's this constant push and pull between order and chaos, this delicate dance between a controlled demolition and a catastrophic failure. And that balance is absolutely essential for us to live.
This constant, invisible drama is at the heart of everything, from how you heal from a cut, to how your body fights off cancer, to the very process of aging itself. So the next time you think about health, just remember this microscopic balancing act. Because the real question, the one at the heart of so much medicine, is what happens when that balance tips too far one way or the other. Thanks for watching.